Hello everyone, welcome to my channel. My name is Thiago. Here we code together solutions to the most interesting and exciting algorithm challenges that we find on the internet. Today we are solving problem number 12 from the website projecteuler.net. The title is Highly Divisible Triangular Number. The sequence of triangle numbers is generated by adding the natural numbers. So the seventh triangle number would be 1 plus 2 plus 3 plus 5 blah 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 until 7. If you sum all of them, you get 28. The first 10 terms would then be 1, 3, 6, 10, 15, 21, 28, 36, 45, 55. This is the 10 terms of this triangle number sequence. So let's list the factors of the first 7 triangle numbers. So the factors of the numbers are like the factors of 1 is 1, the factor of 3 is 1 and 3, the factors of 6 is 1, 2, 3, and 6. In this case, it's like the divisors, right? So 10 is 1, 2, 5, and 10, and so on, up to all the way to 28, the last one they put here. And they say we can see that 28 is the first triangle number to have over 5 divisors. So what is the value of the first triangle number to have over 500 divisors? We're going to have to iterate through this sequence and check the number of divisors that each number has. There are very efficient algorithms to generate divisor numbers, but I'm going to start with the most basic one, which is just like starting from 2 all the way to the square root of the number and test if the number is divisible by any of those numbers in between, right? We don't have to test all of them. We just have to test up to the square root. From that, we know the number of divisors, and we can also use the formula for the triangle numbers. Let's go for it. So let's just create then the problem 12 folder here, and then let's go for problem 12. So as I said, I want to start by implementing a function that finds the divisors of a number, right? So I'm going to name this function get divisors of one number int, and it gives me a set as a result, right? So this function would do then get the divisors of a number, and this should be the input number, and the result should be a set of divisors of n. So I'm going to instantiate then a set that will be the divisors that I'm looking for, right? And every number is divisible by itself and 1. So these two, we can always start with them. Then I want to iterate from 2 all the way to the square root of this number and test the division to see if they are divisible by those numbers. So what we can do here is for every number in the range of 2 all the way to the square root of the number. I'm importing here the math library to do the square root. And the square root gives us a float, so we wanted to add 1 for good measure here and convert this to an integer so that like we can range through the integers. Floats are not allowed. And then we test the division. So if n mod, it means like the remainder of the division by I is equal to 0, then we know that this number is divisible by that number. We can divide that. And then we add them to the set. So divisors.add, we add this number to the set. And if you think that if you divide the number, the remainder is a divisor, but also the number that you get as a result. So for example, 10. If you divide by 2, we know that 2 is a divisor of 10, right? And we also know that the result of that is also divisible by 10, which is 5, because of the property of the division. So we can also add the division here, right? And in the end, we just return the divisors. Let's see if this function works. We're going to do a get divisors, and let's pass the number that they gave us in the example, which is 28. I hope that number is good. We should get these 6 numbers here, right? So let's go there, and let's run the code. Python problem 12. Problem 12. Yes, and we get 1, 2, 4, 7, 14, and 28. Comparing here, 1, 2, 4, 7, 14, and 28. So this seems to be right. Just for good measure, let's test 10, because I can know, like, yes, 1, 10, 2, and 5 are the divisors of 10. So this is acceptable. But the problem asks us to get the number of the divisors, right? So I'm going to make another small function here just to get the number of divisors, right? Again, very simple, but it returns an int this time. I could make it in one function. I'm just separating to have two different functions for modularization purposes. So get the number of divisors of a given number. So total number of divisions. So input number should give like number of divisors. That's what we are expecting as a result, right? Why are you complaining about this? Just repeated. Input n. This is going to be very simple. Just return the len of, and then we call the getDivisors function, and we pass the n, right? Fairly simple. If we just then test this one, we should get a 6 if we pass the 28 here, and that's it. We get 6. Then we solve the half of the problem. The other part of the problem is to get the triangle numbers, the sequence of triangle numbers until we find the divisors, right? There are two ways we can do this. We can do this iteratively, starting from 1 and then get like an incrementer, and then at each step input that increment and sum it up, right, until we get the divisors. Or we can also use a formula for the triangle numbers to generate the triangle numbers. Let's make the two implementations. We can start with like a number n, which is the first element of our list of triangle numbers, right? So it's just the first element, number 1. And we start with an incrementer, which is 1, right? So then I'm going to loop through this sequence. So while the number of divisors of my number n is smaller than, let's start then with the first example, which is 5, right? Is smaller or equal than 5. Then I'm going to add the incrementer to my new number, and then add the increment itself. This should be the solution, and then finally we just print n, which is the number we're looking for. Why I put 5 here? Because this is the example. I want to see if I get 28 as a response, right? If I run this code, I get 56. Something is not right. So the number of divisors of n is 26. Oh, because I made this wrong. This should be this order. First I increment the incrementer, and then I add it. So it's going to become 2 plus 1 that is there. Now it should give us the right result. Yes, 28. Okay, so we can test it for 500 then. Let's go for it then. Running, and we get the result. Let's give it a try there in our to submit this as a response. Okay, 3, 2, 1. Right. Yes, we get the answer to the problem. This is fairly simple, like just iterating through this to this list and calculating the number of divisors. There are more efficient ways to calculate number of divisors, but I believe that my solution here is fast enough. It's giving the response in like 2 seconds or so, but we're gonna leave it like this. There is also something else to discuss about this problem, which is the triangular function. As I said, here we are generating the triangular numbers iteratively, one by one. But we can also do this in a different way, that given an input number, for example, the position of a number in this sequence of triangular numbers, we can generate the triangular number in that position. Let's just implement a function for that. I'm going to call it triangular. Given an input n, it will generate the triangular number in that position, right? And this is the position in the list, in the sequence, and it shall return the triangular number, right? So the formula is fairly simple. It's just n multiplied by n plus 1 divided by 2, right? And since we're expecting an int, right, as output, we need to convert this to integer. Then we're good. So for example, the triangular, let's just print here the triangular number, which one here that we saw from the, for example, the triangular number 7 shall give us 28, right? Exactly. To use this function as our solution, we can do it differently. We can start with our I equal to 1, and while the number of divisors of the triangular number I is smaller or equal than 500, we just increase our incrementer, and in the end, we print the triangular number I. That should solve our problem. We're expecting the same result here. Yes, we get the same result. There is no improvement in the matter of a complexity to the solution by using this function. It's just that I prefer to have a function that generates the position in the sequence than just do it iteratively, right? But both solutions are valid. Both solutions are valid. This is solution number 1, and this is solution number 2, using the triangular function. Yes, very useful. These functions are going to be useful later because I believe there are more problems that requires finding divisors, finding triangular numbers. So later we can modularize this as an utility function. But for the moment, I will leave it like this. Thank you so much for watching. Thank you so much for liking this video. You can click on the like button if you like, or share, subscribe to the channel, turn on the notification bell. I think that this is very helpful for me, for the channel, for everyone. Okay? If you liked it, if you think it's good. All right then. Thank you. See you next.